How is everyone? I hope you're having a great time. Welcome to the last part of week 9 today. It should be a relatively relaxed day. The first part of today is a little bit on Git, which is kind of compulsory, but it only comes up potentially in the exam in a theoretical way. So it's a relatively light topic, and then we're going to be doing a bit of a bonus lecture. So the lecture on Git today, 9.3, is called Git Unscrewing History. What that means is that, we're going to learn about how to do Git resets and Git amends to actually kind of like change what goes on with Git history. And it's like, sometimes we make mistakes when we're using Git, right? You've probably done that before. You've probably been like, oh, I didn't mean to commit that. So you make another commit to get rid of it. Or maybe, you did a few commits and you're like, I don't want any of that. So then you wish you could just like jump back in time, right? And I'm sure a few of you have figured out how to do it. And then also, for those of you who haven't, you probably can feel like Git should be able to do this, right? Like this is the point of a version control software. Like if you couldn't modify the history, it would basically just become, I don't want to call it a blockchain because, it's centralized, but, it would become some kind of, immutable structure theoretically. So we want to be able to kind of change the history in a few different ways. One is we want to be able to do a hard reset at a certain point in time. We want to be able to do a soft reset. We'll talk about the difference between those two. And we also want to be able to amend a commit name. So we're going to kind of step through these things just in a bit of detail. So I kind of just covered this, so I won't repeat the slides, but as I said, we so far have undone mistakes by building more onto the history, and we actually want to have a way to undo that. I mentioned Git hard resets and soft resets and Git commit amend. These are the two kinds of commands that we're looking at today. So even though we're going to be talking about three things, they fall across two different commands, and they're all about rewriting history basically. So the first thing is a Git reset. Now Atlassian, because they own Bitbucket and they're very educational, they have great articles that go through this in a lot more detail. You can go and read that if you'd like to get even more understanding of what's happening. But a Git reset is essentially your way of being able to jump around throughout history and potentially rewrite the Git tree. A Git reset hard, which takes in a hash, because Git resets essentially take you back to a point in time, right? Which is a commit. So like when you're on GitLab, and I think I'm going to use my the demo we did right at the start of the term. Oh no, how do I find it? Personal projects. 1531 lecture 1. Yeah, cool. So I'm going to clone this one. We're going to kind of have a look at this. I don't need to put it in this folder. Git clone 9.3. So the thing is that if you've had a look on GitLab, you'll notice that for all the commits have hashes, right? Now, commits actually have a longer hash. You'll actually see it like a real commit has a hash super long. But what Git actually does is, just for simplicity, it often the first 8 characters are unique enough that like this uniquely identifies it, because the rest, everything after it, doesn't really matter. So all the commits here have hashes, these commit hashes, and there's like 1, 2, 3, 4, 5, 6, 7, 8, 9 commits. So what a reset allows me to do, did I lose the lecture slides? Whoopsie. What a reset allows me to do is to jump back to a point in time based on one of those commits. So Git reset, and then you give it a hash. But the only kind of difference in what you can do here is that you can either do a hard reset or you can do a soft reset with Git. Now they're both very different. A hard reset sets all of your code you have back to a specific commit, right? So it's literally, it's kind of the one you'd expect. It unwinds history. It literally is like a time machine, just going back to here as if everything after that didn't happen. And as I said, I wrote this out in just kind of plain English, right? Which is that Git reset hards are for when you want to say, I want to go back in time and I don't care about anything that's happened since that point I'm going back to. That's the kind of problem that that particular method is solving. And we can see this here. Let's say that in my Git repo, I said, you know what, I actually don't want these 3 commits. I want to go back to whatever this commit was, this adding Hillary commit. So in my repo, I go inside the 1531 lecture 1. Where did that clone to? Oh, 9.3. Sorry. Yeah, I go inside here and then I go git reset dash. Well, firstly, let's look at the git log. You can see the git log has, 1, 2, 3, all these different commits here, all 9 commits. And if I want to get back to, again, adding Hillary, which is this commit here, I can also copy it straight from here. It can be the short hash, it can be the long hash, it doesn't really matter. I could copy it straight from the git log. I often will do resets based on the git log. I won't actually look so much on what's on like GitLab. Then I'll say git reset dash dash hard, and then inside double quotes, I don't think you need the double quotes. I'm going to paste the hash there. And again, it could also be the short hash, the BFD4D3C5 hash, which you can see is just the first part here. And when I do that, and I look at my code, you'll actually see that the code no longer has anything that's like happened here. So for instance, this commit changing name to Hillary, where hello.py was updated from hello world to hello Hillary, that is no longer the case. And in fact, when I look at the git log, you'll see that the git history kind of starts just from adding Hillary here. So as far as Git's concerned, it's just, this is all that exists. It's just these 6 commits. So I've got, 1, 2, 3, 4, 5, 6. Now I've reset that. So then the next question might be, well, okay, that's all well and good. How is this useful? Well, it's useful sometimes if you want to create another branch and go over here, or unwind a change. In particular, it's very useful if you haven't pushed yet. Right? Because I'll give you an example. I'm gonna reset back to the last commit, this one here, so everything's kind of back to normal. It's as if I just cloned it. And now I'm gonna go and make 2 small commits, right? I'm gonna make a new line. I'll call that 1 just for simplicity. I'll go and make a new line. I'll call this one 2, and I'll go and make a new line, and I'll call this one 3. So I've just made 3 small commits, and you can see them on the Git history here. Now, if I haven't pushed to GitLab yet, and I think, oh God, that 3 one was a real mistake. I shouldn't have done that. It's pretty easy. You can actually just copy the hash. I can go git reset hard, put the hash in here, and what it'll do is it'll take me back in time, and now I don't have that 3. Now I can push to GitLab. Now I can do a git push. And this will work because as far as Git's concerned, it had no idea I ever did the 1, 2, and the 3, right? It's like, I didn't even know those existed. So when you push it to Git, Git doesn't see that you did 3 and took away 1. Git just sees what the end result is, which is that you push 2. So now you can see the 1 and the 2 there. Where this gets more complicated is when I say, oh, you know what? Those stupid commits I made in the lecture to demonstrate this to the students, they really were stupid. So I'm just going to unwind those changes. I'm going to get rid of them. So I'm going to reset back to before those commits. So I go git reset hard, put this commit hash, and you can also just type it out too, FFB3DDBA, right? And then on the git log, it's like here. So then I say, oh, well, I like to push that back to Git now. So I go git push. Now what's going to happen is that Git's going to reject this change because Git's basically like, I'm sorry, everything when you push to me, I'm expecting you to keep kind of building the tree, right? Git doesn't like when it can't kind of just add on to the end of the tree in some way. And what it sees you doing here is it sees you set basically what you're doing is you're pushing to Git and saying, hey, the master branch points here to this commit. And Git's like, I'm sorry, but that commit is further behind than what I have on the master branch. This is the exact same problem you have when you have to pull before you push. Like if your team member pushes to a branch and then you try and push, but they've already got stuff there, Git's like, I'm sorry, but stuff's happened since you pushed. So what Git is thinking here is like, hey, I get that you're trying to push this, but you're missing stuff. So it's saying do a git pull, right? It's like do a git pull. But if you do a git pull here, I don't even think anything happens. What even happens? Actually, it'll probably reset your branch. It'll probably like get your branch back up to scratch, I guess. Yeah, so you can see what it did there was it did a fast forward where it modified brendan.py twice because that's the file we did. Because think about what git pull is. Git pull goes and gets the latest changes on master from GitLab and it tries to merge all those new commits into your branch. which it just did. So if I git log now, I have 1 and 2. So a git pull essentially just did what you'd normally expect it to do, but I don't want that to happen. I want to reset my git's history. So I'm going to do that reset again, back to ffb3ddba, right? So my local history now is just here, but I can push this up to GitLab. It's just when I do these kinds of pushes, I need to add a -- force to the end. Now what a -- force does, and it's a very dangerous command, the very dangerous property of a command is that it says, I am going to rewrite the Git history. I don't care what's there, I'm rewriting it. Now, this is why you should always be dangerous with it, because typically if you do this and other people are actively working on it, you nearly force them to reclone half the time, because you just totally remove the history. And a lot of Git's kind of simplicity and stability is based on the idea that you have a common history. Now, are there times to do this? Definitely, yes. Are there times to do this in large projects like your group project? Probably not. It's a lot of trouble, particularly if you've already pushed, right? Like Git resets are great if you've done some local changes and you want to jump back or something. But I wouldn't go near this generally for I wouldn't go this to modifying a master branch in a group project, because lots of people are working on it. But a git push force will rewrite history. So basically overrules the check where it gets like, hey, stuff's happened since you last did this. It looks like you're missing changes, and you're basically saying -- force, I don't care. I know exactly what this Git history should be, and it should be this. This is what master should be. This is what it should be pointing to. So I git push force. You might not even be able to do this on your group repo, to be honest. I'm not sure. Yeah, no, sometimes this happens. So what's happened here is that you can push force to a branch, right? The exceptions that exist, though, are that typically on most projects, right, you have, if you go to settings repository, I don't even know if you can do this, but if you go to protected branches, typically on most branches, there is a protected branch that's master. And this basically tells you that you're not allowed to force push. Now, the reasoning for this should be pretty obvious. Force pushing is not good. It's dangerous. So we block it by default on master. That's kind of the one area you never want to force push, because it's the one place that everyone should have a common history. So what are we going to do? We're going to tick it, because it's our project. You can do this on your projects. I don't know if you can do it on your labs per se. You know, your camera, what's wrong? You can always give it a go. So now that I've ticked that, and I go back to GitLab and I press, do I have to click save or anything? No, I don't. And I click, and I do this again, it will work, and it will update the history. And you can actually see it here. It's actually telling you exactly what happened. Because if I go back to commits, the commit's gone now, but it's saying that, yeah, on your master branch, this used to be the last commit, but I've now forced it to be this commit. And I've got forced update here. So this is a great way to reset your Git history. To go back in time. Diorora says, wouldn't a GUI be good for this kind of stuff so you can be doubly sure you don't mess up? I guess, but I think, as I said, you know, most of the time you're not really going to be doing Git resets on a on like a master branch. A lot of it's going to be happening on your local dev branches potentially. So, you know, there's only so much you can mess up, because typically you're going straight back in time. I mean, you know, this isn't really a tool to do anything super complex, because the only real reason to do this is either A, if you don't want changes in your Git history. A good example of this is if you accidentally push something secret or private on a commit before you push it up, and you just want to like go back a commit and reset it. But a more interesting one, or Git reset hard. That's what you're probably going to use, you know, 99 times out of 100. A more interesting one, just to kind of show that there's different things you can do here, is a soft reset. Now, a soft reset is a bit weird. What a soft reset does is it keeps all of your current code you have the same, but just changes what commit you're pointing to. Now, that doesn't make a lot of sense probably. So it's like, this is like saying, I like the code I have. I don't want to change anything. I just want to alter the history of commits that got me here. Now, if you're a bit unsure what the hell that is, I'll give you the best example of where we use that. I use that on all of your work that you get in this course. And what I mean by that is, like, take your project backend, for example. Do you remember when this was released? You had this commit here, ready for 21T3, right? Or like, yeah, ready for 21T3. This was not a commit, right? I didn't sit down with Emily and we didn't just like make one commit and commit it once and merge it in once or anything like that. We actually had like dozens of commits here. You know, many commits. And what we did was we tried to kind of compress them all into one. But more importantly, what happened was, if you imagine for a second that you have all of your commits like this, these are all very ugly commits. You imagine you have all of your commits like this, right? What a git reset hard is a git reset hard back to say here is like saying, actually, I don't want any of the code in any of these. I want to just come back to here. Whereas a git reset soft says, I actually want to get these off the git tree, but I still want to keep all the code in it. So it's really a way to leave your code the same but change the git history. Now the reason I point that out is, let's imagine for a second that this repo here is a lab that I would like to share with this cohort, right? I'd like to make a lab for you. And I like all the code in it, right? Everything's good. I don't want to go back in time. I want to leave it as it is. However, I don't want you having to either see all the crappy commits I have, or I don't want you to get confused by it because you're new to Git. It's week 1 of 1531. I don't want you to see this and be like, why is there colors? And this is clearly, I don't like, you know, these are clearly, I don't even know. These would be 2 different computers here or something, I guess. Yeah, I guess one of these would be, yeah, anyway, they're different computers. So I just want to kind of make it nice and concise. So what I can actually do here is I can say, well, I would like to actually go back to the very first commit, for instance. Now, when I say go to the commit, I mean like keep the code the same. I don't want to reset everything. I want to keep all that code there, but I just want like my history to go back there. So if I do a git reset soft instead of hard, and then I paste in the hash, and then I click enter, what you'll notice is if I git log now, we've gone all the way back to this adding hello.py commit. So this is the only commit that's been made on the repo so far. And if I do git status, all of the different changes that I've made to date, like this one, 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 and this one, all of them have essentially, instead of being actual commits, they've been kind of dumped into the unstaged commit area, as if like they're waiting to be committed. So again, if you think about it, in the past we used to make a change, stage it, commit it, make a change, stage it, commit it, make a change, stage it, commit it. Now it's kind of like all this stuff is just sitting there, staged, waiting to be committed in one go. So when I then say here git commit -m ready for 21T3, right, and then I go and try and push that back up, it's going to fail again because you're trying to rewrite history, and Git's like, I'm sorry, and Git's even more confused here because it can see that you went from this git commit hash 30C2 to this git commit hash A4D5, and Git's looking at this and it's like, I have no idea how you did that, right? It's like the merge problem again, because as far as GitLab's concerned, there was just like these 10 commits over here, and you're coming along and saying, no, it starts at the same commit, but it goes in that direction. So Git's like, I'm sorry, I just can't take those requests, because if you remember, we said that all resolutions happen with a pull, and when you push, Git always expects you to just be logically building onto the tree. So how can I get around this again? I can do git push force, which tells Git, no, take this, I know exactly what I'm doing, go rewrite the history, and when I refresh this page now, those commits have gone, but the code's all still the same. I still have my, brendan.py, which still has my print in it, and everything else you'd expect. So Justin's questions, are hard resets used more often? Yeah, they're used more often. Blake says, what's the difference between resetting and just checking out that hash? That's a good question, actually. I think I have a memory that Atlassian explained this well, but I don't know where. Yeah. So I won't go into it in too much depth, but it's like if you imagine that this is your Git commit history, and you clone a repo and you've got 4 commits, and there's your head or your main. When you and like your head's like where you're looking at, whereas your main is essentially like what your local code is aware is like the tip of the tree. I'm pretty sure. I don't use a lot of Git checkouts for commits, so that's why my language isn't super confident. But when you do a Git checkout B, you're essentially moving your head, as in where you're looking, where you're checking out, back to a previous point in time, but you'll still see all those other commits there. So for instance, I'm just guessing here, if I say git checkout and then I do a git commit hash like 30ce2e68 here like this, oops, what's the command again? Git checkout B, isn't it? Oh, headers, oh, it works, yeah. So now when I git status, head detached, yes, this is when you get the head detached thing. So you see, in the git log, so we have gotten rid of it. I'm not 100% sure. Yeah, so like, so you can your head is detached from where the main item is at the end here. You haven't really reset anything, you're just kind of exploring around. I think that's one of the main differences. Whereas a git reset will actually move what Git is aware is the end of the commit tree and where you're looking to the same spot and kind of just get like everything else is just kind of pushed away for a minute. I don't want to say it's deleted per se because of how Git works with commits and branches as kind of separate ideas, but that's the main difference with a checkout. I think if you sat down and read it and play around with it, it'd be a bit more intuitive as well. Waleed says, what's the best way to reset master completely? For example, you've rebuilt your code base for a project in a new language and you want master to be totally different, but within the same repo. I mean, if you're totally rebuilt your project, I'd probably generally recommend you make a new Git repo, but I understand there are scenarios where you might not want to do that. Or in some cases, well, there's so much you can do with Git. Let me start with that. Like, you can squash things as separate ideas. That's a whole other topic, Git squashing. I don't know if big companies do it, but maybe maybe after 5 years, you go and squash all the old commits in a Git repo. So there's just like less crap in the repo. Probably not, but there's lots of other cool tools you can do. If you want master to be totally reset, you could just git reset master. I'm just saying on projects where you have multiple people working on it, resetting master essentially means everyone needs to delete their repo and reclone. It's not literally, they're not literally required to, but effectively that's kind of what happens half the time because you've polluted the Git history, which also means that like if someone's working on some branches that are branched off master and you've reset master and you're trying to build it up in another direction, like it's all wiggly woogly, right? So generally that's kind of, something you do if you're working by yourself, maybe. Yeah, so that's Git reset hard and soft. Hard's a lot more kind of common and useful because it's just getting rid of stuff. And I gave you the soft example because the only time I've ever done a soft reset is for your tutes, for your labs and stuff. And also like soft resets aren't that different from a Git squash, right? And I don't do a lot of Git squashing on command line because most of the squashing I'm interacting with happens on merge requests, right? Which is kind of what's happening here, where if you have 10 commits on master and your branch has another 5, when Git merges that in, you can actually compress those 5 commits into one, right? So squashing is kind of a merging thing as well. And I guess reset soft is kind of like an ability to squash when you're not merging, right? So you can actually, because that's what's happening, right? Like squashing is taking the same code and compressing it into a commit. That's exactly what I've done here. I just haven't done it through a merge request or anything like that. So that's why when you make a merge request, you'll see that stuff about, I don't know if I have any branches here. Don't think I can do that. Yeah. That's why you'll see that stuff about do you want to squash, and we tell you not to in this course just so we can make sure that we can like track your contributions, right? Because the last thing you want to do is do code over 3 days and be committing regularly and then squash it, and then your tutor's like, you did it, you only worked 1 day this week, or like and you're like, no, I didn't, I squashed it, and they're like, prove it, and you're like, I can't, because, well, you probably can if you have a local branch, or if your branch is still on GitLab. That's also why we tell you not to delete your branches, because in reality, I don't know how much I chatted about this back in week 1, but in reality, if you're working on most, I guess, industrial projects, your merge requests are nearly always squashed, right? And your branches are nearly always deleted once you're done, because the kind of the philosophy of Git in a lot of ways, I think, is that you have a master branch that is all of your code totally stable, very clean, and every time you make a branch to fix a bug or add a feature, and you're in a constant state of wanting to get rid of all those branches, because if branches exist, it means you have unfinished work that is yet to be stably integrated into master, right? So deleting a branch is like trimming it off, and you're always trying to bring that back into just nothing, I guess. On to the last point here, and then we'll take an early break before the front end stuff. Git commit amend. If some of you were paying attention, you probably noticed how, oh god, I don't know how to get out of a, this is where resets are actually also really useful. Because like now it's like, I don't know what I've done here, so I can actually just go find the commit I want, this one, and I can just, it doesn't have to be an older commit, it can be like a newer commit too, git reset hard. And that just jumped me ahead then, and then everything's like fine again. But you know, I need to check out master. Check out, like, yeah, and this is the important thing, right? Like, think about reset as altering your Git history, and think about checkout as you deciding what commit you're looking at and other things. Or go read about it more. And none of this detail is expected about checkouts and stuff anyway. So here is the problem we have. I don't want it to say adding hello.py and then this. I want to get rid of this commit. I want to squash that down totally. But the problem is every time you commit, you are adding another thing. So we have this idea of a git commit amend, which is a really interesting idea where, say, let's say I modify brendan.py, right? And now I've got, you know, I go add brendan.py, I go git commit, adding new line. Instead of making like a third commit, right? I want to just rename this commit. So I can actually add the -- amend flag to the end of that commit command. And what it will do is it will simply override this commit. And let me just copy and paste this so we, you know, I guess have an example of it. Right, so that's our current commit we have. And now, when I come down here and I add that -- amend, and I look at the git log, have a look how this is different here. The time is the same, the author is the same, the commit hash is different, and the name is different. So the name is different, that makes sense because we gave it a new name. The author and the date not changing, that also kind of makes sense because the amend is just to amend the name of a commit. But you notice the git hash is changing, and this makes sense because, you know, Git's a fairly strong, largely immutable structure, and what it means is that if you try to push this to GitLab now, it's not going to be under any illusions that this is something different to what it was before. You could imagine the kind of chaos from a software perspective if you could make changes to commits, push them to GitLab, and then GitLab doesn't have a way of telling that that's different. So every time you commit, whether you're amending or whether it's another commit on the tree, you are always going to be creating a new git hash. And again, if I try and push this up to GitLab, Git's going to crap its pants because it's like, hey, I went 30 here, A4 here, and you're like, locally I was at 30, and then I went to whatever the hell this commit is, 1.3 or something. So similarly, we need to do a force here to get it done, and that will update the commit. And this is again what I do with your tutes and labs. I go git log, I look at the old commit, I go git reset soft 30c2e, right? Now I git status, I see all the files there, I git commit them, I'll say ready for 21t3, I'll amend the commit, because remember, we've reset to the first commit, so we want to override that first commit, and then I'll push force to GitLab. And then it's all packaged up. Now here's the thing, we can't actually, like, we only do that for the first commit because you could imagine it's a bit problematic if, like, you'll notice this with the project, as we make changes to the project, if Emily went and made 3 fixes and then reset them, if any of you had pulled the latest changes from us in that time and Emily kind of reset soft them and collapsed them, it would break everyone's stuff. So it's kind of like once an item is released and everyone's using it, there's no more soft resets that happen. We just like push more commits on top onto the branch. Waleed says, in real life, if you ever end up having to git reset an important branch, do you communicate that to your teammates or do you make them aware? Look, I mean, it's in my view, it's typically you're either git resetting your own branch, which no one else is probably working on, or you're git resetting master, which you probably shouldn't do anyway, and you're probably not allowed to do based on the git rules that exist anyway. So that's kind of the crux of that. Are there any questions about this? Because it's meant to be a short lecture. I actually spent more time on it than we thought. But if you have any questions, that'd be good. Otherwise, we can fill out some feedback and take an early break. Alex's question, when would you want to use this? I mean, Git reset softs are essentially when you want to squash commits but keep your code. Git reset's harder when you want to go back in time. Git reset hard is going to be a lot more kind of common. As I said, the surface area in which I've used a soft reset is extremely small. So, yeah. So yeah, please share some feedback. Phone out, just a little snap, and then takes 5 seconds on a form. Always appreciate it. So thank you in advance for all these things. Let's take a 5-ish, 10-ish minute break. 10 minutes say, and then we'll get stuck into some front end stuff, and it's a bonus lecture. You can head off and go back to life now, and we'll just have some fun. So thank you.